Hello everyone. So it's 6 o'clock and I will wait for 10 more minutes. And as the students will join, I will start the presentation at 6:10 p.m. We will wait for 10 minutes and then start the presentation at 6:10 p.m. Also, I have shared the week 1 presentation link in the chat box. You can access that link to see the previous recording of the last week. Okay, so we'll start the presentation now. Hello everyone, my name is Arient Ahuja. I am your PMRF TA for the course of Biomass Conversion and Biorefinery. And today I will be giving you a brief on week 2, the assignment problems of week 2 involving questions from 2021, 2022, and 2023. The course coordinator for Biomass Conversion and Biorefinery is Professor Kaustubh Mohanty from the Department of Chemical Engineering, IIT Roorkee, and I am currently doing PhD under the Professor Vibhor Kumar Rastogi from the Department of Paper Technology, IIT Roorkee. So, first of all, can you all see the slides? And am I audible to you? Mirabai, Praveen, am I audible and are the slides visible?
Yes, yes, yes.
Okay. So, some before going to the slides, I will give you a brief note about me. I am Aryant Ahuja and I have done my BTech in chemical engineering from Kumaon Engineering College, Dorahat, and then I did my MTech from IIT Roorkee in packaging technology and currently doing PhD in paper technology from IIT Roorkee. And I am receiving Prime Minister Research Fellowship from 2021 on the project of paper-based value-added products. Today we will be discussing about the week 2 assignments of 2021, 2022 and 2023. So we'll start from the 2021 and I would like to make it a more like an interactive uh, presentation. So please, I will ask you the questions and you if you don't know the answer you can just guess it and it don't worry about that if the answer is right or wrong, just you can make a guess also. So question one of assignment two in the year 2021 was which continent have biomass as the largest renewable energy source? Asia, Africa, America, or Europe? So, anyone want to make any guesses about this?
Africa.
Africa, yes. So, Africa is the largest renewable energy source and they have nearly 49.6% dependent upon the renewables. Africa has the largest share in renewables for their energy demands, and the lowest renewables which continent uses it is Europe. Europe uses the lowest renewables that is 10.3%. This I have shown in previous lectures also, as this question was in assignment 1 of 2021. So, moving forward quickly, the oil fraction of Jatropha curcus consists of what type of fatty acids? Saturated fatty acid, unsaturated fatty acids, or both? And the last option, none of the above. Any guess anyone wants to make? You may either speak or write in the chat box, whichever feels comfortable to you. Any guesses? Okay, so no guess for this question. The right answer is both saturated and unsaturated fatty acid. Jatropha has both of these fatty acids. But before going towards it, I will explain you what is Jatropha. So Jatropha curcus is a species of flowering plant in the spruce family. It is native to American tropics and Mexico and Central America. Jatropha oil is produced from the seeds of Jatropha curcus. So the Jatropha oil or the biodiesel which we hear mostly in the era of 2010, it was made of Jatropha oil. And if we move on to what is fatty acids, so fatty acids are nothing but long hydrocarbon chain, and at last they have COOH. So it is nothing but a very long chain of carbon, and at last it has COOH. COOH is a carboxylic acid, so it is known as acid, and it is a very long chain, so it is also known as fatty acid because long chain contains fats. So that's why it is known as fatty acid. But what is the difference between saturated fatty acid and unsaturated fatty acid? Saturated fatty acids have single bond. If we see in this diagram, every carbon atom is connected with a single bond. So it is a saturated fatty acid compound. But if it has a double bond in them, in between or any other place, if it will be having a double bond, then it will be known as unsaturated fatty acid. So, have you understand the difference between saturated fatty acid and unsaturated fatty acid? Saturated means a compound which has single bond, and unsaturated means a compound which may have one or more than one double bonds in between the carbon atoms. So, the Jatropha oil has both of these types of oils, both these types of fatty acids. It has both single bond and double bond both. If we see particularly for the composition of Jatropha oil, it mainly consists linoleic acid, which is 47.3%, which makes up to the 47.3% of the Jatropha oil. And if we see here, it is written C18-2. C18-2 means it has a chain length of C18. There are 18 carbon atoms, and the 2 represents two double bonds present in it. So, linoleic acid is the major component of Jatropha oil, and it has a carbon chain length of 18 with two double bonds, and rest are single bonds. And if we go for the other components such as palmitic acid, so it has palmitic acid also, which is 11.3%. And palmitic acid, it is written C16-0. C16-0 means it has 16 carbon atoms with zero double bonds. So the palmitic acid is saturated fatty acid. Linoleic is unsaturated fatty acid. So therefore, Jatropha oil has both types of acids, that is saturated fatty acid and unsaturated both. And if we see here, linoleic acid, which is present in very low quantity, zero point 0.2, but it has written 3. So 3 represents 3 double bond atoms. And in the case of 1, C16-1, it means that only single one double bond was there in the whole 16 chain. So I hope that you have understood what are saturated fatty acids, unsaturated fatty acids, and Jatropha oil has both of these acids. It has both the components. So the answer was both saturated and unsaturated fatty acids. So now let's move on to next question. Oh, sorry. Some more things about Jatropha I will discuss. Jatropha is a low-cost biodiesel feedstock with good fuel properties and more oil than other species. It is a non-edible oilseed feedstock. So the major thing about Jatropha is that it is not edible. So it does not have any impact on food prices or the food versus fuel debate. Mostly when we look at the fuel, uh, the first generation fuels were sourced from edible compounds, edible plants. But when we utilize the edible compounds to make some type of energy or oil, then there's a debate that we are utilizing our own food to produce energy. Then there might be a shortage of food. So, second generation um, fuel came, which were made from non-edible soil. Jatropha was one of the second generation fuel, as it is made from non-edible plant. Okay, and Jatropha also Jatropha biodiesel also contributes to carbon net neutrality. How? If we look for that, we can see the whole life cycle of Jatropha. So the Jatropha seeds are obtained from the Jatropha plant, and then oil is extracted from it from chemical and mechanical processes. After that, we do the trans-esterification process, which we will study in afterwards and in other lectures. So the chemical reaction is done to convert that oil into the biodiesel, and this biodiesel can be utilized to transport or do other things, and can be used for agriculture also. And so it can again used for Jatropha plantation. So this whole cycle means that it has attained carbon neutrality. So everyone has understood what is Jatropha, what is unsaturated fatty acid, saturated fatty acid, and how it is doing carbon neutrality for the environment, and about the second generation of oils. Has everyone understand that? Praveen, Vignesh, Mirabai. Okay. So now I'll move on to the next slide. Which of the following crops are classified as herbaceous crops? Hardwood and perennial, softwood and grain, perennial grass and grain crops, or hardwood and grain crops? Which might be these? Which might of this combination might be a herbaceous crops? So, first of all, I will give you a hint. Herbaceous crops are nothing but a type of herb plant. So, which you think might be the herbaceous crops? Any guess, anyone? You can write in the chat box if you don't want to come on the mic. Feel comfortable and don't think that the answer might be wrong. I just want to make it more interactive.
The perennial grass and grain olive crops and bitter wishes.
Yes, correct. So, perennial grass and grain oil are herbaceous crops. So, first, herbaceous crops are nothing but it has the characteristics of an herb, and these are particularly vascular plants that have no persistent woody stems above ground, and they are classified following life cycle classification as annuals, biennials, or perennials. And these also include non-woody plants such as ferns, grasses, or oil crops. So yes, herbaceous plants have perennials and oil both in it. But what is a perennial? Perennial grasses are nothing but a plant that lives more than 2 years. So if a plant lives for more than 2 years, it is known as perennial crop. And perennial grasses, a type of perennial grass is a lawn grass. So lawn grass is a type of perennial grass. It lives for more than 2 years. And oil crops are those crops which are rich in oils, proteins, minerals, vitamins, or any other dietary fiber. So, such as soybean and canola oil. So, soybean and canola plants are majorly used for oil production as they have high lipid content. So, they are a type of oil crop. So you might have now get a idea about the perennial grasses and oil crops and what are the herbaceous crops. So let's move on to the next question. The main index determining the potential of microalgae strains as biodiesel feedstock are lipid growth, growth rate, lipid productivity, or all of the above. Any guess? Anyone?
Lipid content is high, like maybe.
Okay. And anyone else? Not many people are interacting. Okay, so no worries. Lipid content, yes, is a term that determines the potential of microorganisms, but growth rate of microalgae and lipid productivity both also determines the potential. You see, the growth rate of microalgae, the higher the microalgae chain, the higher the lipid and it can produce. So yes, growth rate will is also the right answer. Lipid content, yes. If we want the more biodiesel, then we need higher lipid content of that microalgae chain also, and lipid productivity also. We also require lipid productivity of the microbial microalgal strains also. So all three are the right answers for this question. Okay, so who is the largest producer of sugarcane in the world? India, Brazil, Canada, or Pakistan? It's a type of GK question, but it has been updated now. So in 2021, the answer was Brazil, but now it is India. So the question was asked in NPTEL 2021, and that time the Brazil was the answer, correct answer. But now, as of past 2 3 months, India has become the largest producer of the sugarcane in the whole world. When we look at the Indian map, the largest producer of sugarcane is the Uttar Pradesh, Maharashtra, and then Odisha. The darker brown part are the states which produces 500 to 1500 lakh metric ton. But this data is old. This data is from 2011 to 12. But Uttar Pradesh is producing the highest uh, sugarcane now also. So let's move on to the other question. Water use efficiency, also short termed as WUE, is defined as the ratio of biomass accumulation to the water consumed to the biomass accumulated, or water consumed for biomass accumulation to the total water supplied, or last, none of the above. Anyone? Just make a guess. A, B, C, D, any guess. That what we do we understand from this term? Water use efficiency. No guesses. Okay. So the correct answer is biomass accumulation to the water consumed. So if we look for the term water use efficiency, it says that the efficiency of the water that can be used by a biomass. So biomass accumulation to the water consumed. If the biomass consumes less water, then it might be a good efficient biomass. So that's why the term has came to define such type of property. If we go into more deep, water use efficiency is determined as the amount of carbon assimilated as biomass or grain produced per unit of water by the crop. The, in other terms, we can also say that the quantity of water consumed by crops is estimated according to the total number of water used from the plants and soil surfaces, in addition to the retained within plant structure. However, the total amount of water retained within plant structure is less than 1% of the total water consumed during the growing season in a normal year. So we only consider the total amount of water used. We don't consider the water retained within the plant because it is just 1% of the total water consumed. For to make the easier calculation of WUE, we only consider the total water consumed by the plant. And how does the plant consume water? In what way? It consumes for transpiration. It takes the water from the soil and transfer to all the parts, and also evaporation of water from the plant to the atmosphere. So in both the ways, plant is consuming water from the soil. So this consumption is only calculated for water use efficiency. If it is retaining some amount of water, we will not use because it is just 1% of the total water consumed. There has been a long great interest in developing and understanding how to improve WUE and modify farming systems in both rain and irrigated agriculture. See, if we want to improve the WUE, we can also uh, uh, we have to use less water. But how a plant can use less water and grow in at the same rate? So, a process known as mulching is used. Mulching has been effective in improving the yield and WUE. The, the process of covering the open surface of the ground by a layer of some external material is called mulching. So you see, we if we cover the open surface of the ground by a layer of some external material, this is simply called mulching, and the material which is used is called mulch. So when we cover the ground by some external layer, the evaporation we can reduce the evaporation of water from the plants to the atmosphere. So in this way, the we can also reduce the water consumption of plants, and so we can improve the WUE. Mulching also reduces soil evaporation and increases crop transpiration as it also increases water harvesting. So now we'll move on to the next question. If there is a decrease in lignin content of the biomass, the accessibility of the cellulose microfibril to degradative enzyme will be. So before going into this question, I want to ask how many of you know what are lignin and what are cellulose microfibril? How many of you know this? Okay, no responses. Okay, so do you want to make any guess that what is the role of lignin on the accessibility of cellulose microfibril to degrade enzyme? So I will tell you a little bit about it before you make a guess. Cellulose is the major structure of a plant. It it is a primary structure in the plant of the in the wood or non-wood or leaves, and it is protected by a sticky substance which is known as lignin. So lignin protects the cellulose by forming a network onto it. So if some enzymes want to degrade the microfibrils, lignin will not cause that degradation. So the answer is it will enhance, because as lignin will decrease, the accessibility will increase. So if the lignin is lesser, then the enzymes can go easily to the cellulose. So the accessibility will enhance. To explain this, I will explain it more clearly. Lignin is an important organic polymer which is abundant in the cell wall of some specific cells. It has also many biological functions such as water transport, mechanical support, and resistance to various stresses. Lignin is the encrusting material in which the cellulose microfibrils are embedded. So, microfibrils are embedded in the lignin. So, lignin makes a cover around the microfibrils and protects it. It also lignin also act as a binder. It also it due to its sticky. stickiness property. It is a sticky material and thus make availability of cellulose less for any type of modification. So if we want to modify any type of, if we want to do any chemical modification to cellulose, we have to remove lignin. So if we want to do enzymatic degradation of cellulose, we have to remove the lignin. And to explain more about it, this is a picture of a tree. And if we go into the microstructures of the tree, it has different strands. And if we look for this particular strand, it has many microfibers. In these microfibers, there are three types of microfibers in it. One is cellulose, second is hemicellulose, and third is lignin. So cellulose and hemicellulose are both carbohydrates, and lignin is a polymer, sticky polymer, which binds these two together and protects it. So, if we want to do any um, degradation or any type of hydrolysis or any type of chemical changes to the cellulose, we have to remove this lignin. And have everyone got this clearly? That what is the role of lignin in a plant? It protects the plant and also act as a binder for cellulose and hemicellulose. Has everyone understood it, or should I revise it again?
Okay. No, no, it's understood. So
Oh,
one thing is, yeah, what type of compound lignin consists of? Is it carbohydrate or any other?
actually, lignin is a very complex compound. We cannot define a structure for it, as
Uh,
it is obtained in like it is if we obtain lignin from a different tree or different plant, it will have a different structure.
okay,
But majorly, lignin has a OH bond in it, but it is still not hydrophilic in nature. It will be a hydrophobic in nature. Lignins are particularly considered as hydrophobic. And as you also may know that paper, the writing paper or printing paper which we use are made from these woods. So when we make this paper, we remove the lignin from this cellulose and hemicellulose, because lignin also act as a lignin gives a brown color to the paper. So to make it white, we first remove the lignin and then bleach it. So in some ways, lignin is not considered as a good thing because it makes paper brown, but it also has hydrophobic properties. So it can be used in other ways also. And particularly for biomass energy, if we want to convert cellulose into a fuel or into of energy form, then we have to remove the lignin, because the presence of lignin reduces the um, effect of other chemicals on the cellulose.
okay,
Okay, so there is a question of a numerical question. In 2021, a numerical question was asked, and the same question was asked this year also. So, first of all, how many of people have done this question this year? In assignment 1, this question in assignment 2, this question was given this year also. Nobody? Okay, so basically, the question was like simple fuel was given, a fuel oil with a specific gravity of 0.893, and we have to find the effective thermal conductivity if the moisture percent on dry basis was 50%. So the answer was 0.36, And if we calculate it, the answer was coming 0.3558. The formula which we will use for this is the second formula. Oh, the first formula. You see, when the moisture content, also shown as MD, MD means moisture content on dry basis. So if the moisture content on dry basis is more than 40%, then we will be using the first formula for finding the thermal conductivity of the oil. And it is, if the moisture content is less than 40%, then we will be using the second formula. So in this question, we had 50% moisture percentage on dry basis. So if we use this formula and simply put the values, just like if we use 50 in terms of MD and 0.893 in place of specific gravity, we will just obtain this value. So if we round off this, the value is 0.36. Hence, the answer was C. This formula was also in the NPTEL lecture of last I remember it was in the lecture 4th or 5th of week 2. And if the moisture content in this question will be replaced by, let's say, 30%, and the rest values are kept same, then we will be using this formula, the second one, because the moisture content is less than 40. So I hope you may have done this question in the assignment too, and if not, I hope you have get the basics clear from this slide.
Yes, yes.
Okay, so let's come on to the ninth question. The pre-treatment and hydrolysis efficiency of biomass is greatly influenced by. So the pre-treatment and hydrolysis efficiency of biomass, particularly which we were talking about in previous slide also, that if we want to do any type of chemical reaction on the biomass, in this case cellulose, then what type of things will influence? Compositional changes, difference in ultrastructure, both A and B, or none of the above? Any guess? But I hope that you will make a right guess this time, because there was a hint in 2 3 slides back.
Both A and B.
Both A and B, yes. So both A and B will affect the hydrolysis or pre-treatment efficiency. So if we look for the compositional changes in the plant cell wall has the lignin inside it. So yes, if the plant cell wall has less or high lignin, it will affect the dissolution or any type of chemical changes on the cellulose. Difference in the ultrastructure. The ultrastructure has hemicellulose and cellulose also, and we need to remove the hemicellulose also. So yes, if the ultrastructure is different, then the efficiency will change. So the correct answer is both A and B. So there are other factors also which influences the hydrolysis of biomass. They are crystallinity of cellulose, hydrophobicity of lignin, if the lignin is more hydrophobic or not, and embedding of cellulose in lignin and hemicellulose, which we have discussed, that lignin also affects, the presence of lignin also affects the chemical changes of cellulose. And let's come to the last question of 2021. What are the major advantages of vegetable oils for use as diesel fuel? So, what are the disadvantages of vegetable oil? Higher viscosity, lower viscosity, reactivity of unsaturated hydrocarbon chain, or all of the above? which might be the disadvantages of vegetable oil? No guesses? Vignesh, Praveen, Lakya, Suman, anyone want to make any type of guess? Mirabai, any guess? You might be
all,
right.
all,
Can you repeat it again?
all the above.
All
Hello.
of the above. Yes, all of the above. Vegetable oils are not very volatile. When we see the diesel fuel, which we use in automobile, diesel evaporates very rapidly. It evaporates very rapidly. But when we see the vegetable oil, which we use in our kitchen house, they are not volatile. We need to boil them at above 200 degrees Celsius. So it is less volatile and it is higher in viscosity. Vegetable oils are less less flowable than diesel, or in other words, you can say that it is highly viscous when compared to diesel fuel. Also, reactivity of unsaturated hydrocarbons makes it another disadvantage is because vegetable oils are very long chain fatty acid, just like jet oil also. So all these three reasons make disadvantages of vegetable oil. Some facts about vegetable that why particularly what is the relation of with it with diesel. Viscosity of vegetable oil is 10 to 20 times than diesel. So if we will use it in replace of diesel, there will be many problems such as poor atomization of the fuel, incomplete combustion, or choking of the fuel injector because of high viscosity. But it has been seen that if we mix vegetable oil with diesel, then this produces a low viscosity oil, which we have observed in the past experimentations. So the blending of vegetable oil with diesel is being done to utilize it. And as of now, the highest consumption, as I remember, is 10%. We have used 10% of vegetable oil with diesel for blending so that we could utilize those vegetable oils for the fuel purposes. But it cannot be used as a single standalone fuel due to the high viscosity. Now, let's move on to the assignment of 2022. 2022 and 2023, both of these assignment have similar questions, so you might have known the answers of this, but I will give you the detailed explanation also, which will help you in the further examinations. So, due to the blank structure of hemicellulose, it is significantly more susceptible to hydrolysis than cellulose. So, what do you think? Due to the crystalline, amorphous, semicrystalline, or none of the above?
Amorphous.
Amorphous, correct. So, amorphous is the right answer. Due to the amorphous structure of hemicellulose, it is significantly more susceptible to hydrolysis than cellulose. But before going into it, I will explain you what is hemicellulose. So, hemicellulose is a heterogeneous polymer composed of many type of sugar, such as xylose, arbanellose, mannose, and galactose. It is composed of many types of sugars, and it is a water-loving compound also because it is very rich in OH bonds. You see, there are many OH bonds present in it. Whenever you see OH in any type of compound, you can make a small assumption that it might be hydrophilic or water soluble or water loving compound because water is also a type of OH. So, hemicellulose is a heterogeneous polymer composed of many sugar and it is hygroscopic Hygroscopic means a compound which can absorb water in it. And hemicellulose is the second important constituent of wood. What is the first important constituent of wood? It is cellulose. And second important is hemicellulose. So hemicellulose, we can have seen that it is a sugar polymer. But cellulose is not a sugar polymer, it is a glucose polymer. So this is the major difference between cellulose and hemicellulose. And as we have also seen that the answer was amorphous. That amorphous structure of the hemicellulose make it more susceptible to any type of any type of chemical changes when we compare it with cellulose. Why is it so? Because of its amorphous structure. What is the difference between amorphous and crystalline? A crystalline structure means that there is a pattern in the inside the molecules atoms. There's a definite pattern, there's a short chain and ordered structure. Particularly we say it is an ordered structure. The structure is very ordered. But in amorphous there is a type of randomness and mix of long and short chain. It is also known as unordered. So when anything is unordered, there is not any pattern in it, so a chemical can easily penetrate and change the molecules. But if anything is has a crystalline structure, then the chemical changes are not that easy. So the amorphous structure of the hemicellulose make it more susceptible to any type of chemical changes. Now let's move on to the second question. Which of the following is true for light reaction in photosynthesis process? Yeah, we give emphasis on the light reaction. There are two types of reaction in one is light and dark.
Oh, CO2.
Okay, so yes, correct. Answer is C. Splitting of H2 molecule into H2 and O2. The above two, A and B, are particularly for dark reactions. So this question was about light reaction. So I will explain this in the next slide. A light reaction, also known as photolysis reaction, takes place in the presence of light. As the name goes, light reaction, it happens in the presence of light, and it usually takes place in the grana of chloroplast. Light reaction is the first stage of photosynthesis. In the first stage of photosynthesis process, the light reaction is the first reaction in which solar energy is converted into chemical energy. So the light is from the sun is converted into chemical energy in the form of ATP and NADHP. So light reaction is a photochemical reaction. It is not a biochemical reaction. And whereas if we see the reaction involves in dark reaction, H2 hydrogen is transferred to the CO2 to form starch or sugar, which is particularly a biochemical reaction. So the first two options were of dark reaction, and the C option was for light reaction. Okay, so next question is anthropogenic ash in biomass mainly consists of
Silica.
silica. Correct. So there are two types of ash. One is anthropogenic and one is intrinsic. So I will explain both in the next slide. But in this, I will need to say that the calcium and potassium, these both are intrinsic ash. As the name goes, intrinsic, so it means that it is produced from biomass, inside the biomass. And silica is anthropogenic. Anthropogenic, the word anthropogenic means from the outer world. So it's a type of ash produced from the outer world. So yes, the answer is silica. So the anthropogenic activities include which anthropogenic activities are mainly done by humans by us, not by biomasses. So anthropogenic activities includes mining, release of industrial waste, smelting, incineration, uh, particularly coal, or utilization of arsenic-loaded water for irrigation, or arsenic-based pesticide, herbicide, and fertilizer, and many other things. any type of human activity which we do externally is known as anthropogenic activities. Or we can say that anthropogenic term explains that the pollution or environmental change originating from human activity. So it is like so anthropogenic ash. If we see an intrinsic ash, if we see both these terms, it will get to our mind that, and if a ash is getting from outside, it is an anthropogenic ash, and if it get is present inside the biomass, then it is known as intrinsic ash. So intrinsic ash is calcium and potassium, and anthropogenic ash is particularly silica. So I hope that you have understand the types of ash, such as anthropogenic ash and intrinsic ash, and how to identify them. That intrinsic ash is present inside the biomass, and anthropogenic ash is getting added from the outside world by human activities. So, yes, this question was repeated again in the 2022, that what were the main disadvantages of vegetable oil as diesel fuel. The same question was in 2021 also, and we have discussed it earlier that the answer was all of the above. The higher viscosity, higher cost, and lower volatility of vegetable oil is the disadvantages. So it cannot be replace the diesel fuel, but we can blend it and utilize the vegetable oil in by blending with diesel fuels. So the fifth question: biofuels for microalgal biomass are first generation, second generation, third, or fourth generation fuel. Anyone wants to make any guess? And I have explained the first and second generation also in the second or third slides.
Second generation.
Okay. And anyone else? If somebody is not feeling to say on the mic, you can also write in the chat box. Feel comfortable and don't think that you might be wrong. Just feel
Can
comfortable.
you can you please explain all these first, second, third, and fourth
Yes, yes, I will
generation?
explain all these four. Okay, so the correct answer is for this is third generation. So third generation biofuel is microalgal biomass. So how does this generation came? How why do we say it a generation? How who has given the word generation to it? So first we will see the it we are talking about the biofuel. So the first biofuel which we had obtained was from the edible crops such as sugar-based compound like sugarcane, sugar beet, and sorghum. So the first type of biofuel which we made in the past eras, was from sugarcane, sugar beet, and sorghum. As these were mainly edible crops, so these didn't came in the industrial application because the food war came. But people used to say that why to utilize food for energy, which we are already eating. But that has created the a concept to make fuel from crops also. So that was called as first generation. So first generation was edible energy crops, and then came the second generation, which is non-edible. So second generation came to replace the first generation, and that was non based on non-food, or we can say non-edible, which we don't utilize for eating. So there was no food war for it, that we are not utilizing any type of food, and these were mainly based on lignocellulosic biomass. And what is lignocellulosic biomass? It is nothing which but it is a term used to define any type of tree crop, stem, leaf, anything which has lignin and cellulose. So if a tree has lignin and cellulose, it is known as lignocellulose. So the lignocellulose has come from lignin plus cellulose, and this biomass, the energy from lignocellulose biomass was known as second generation because it was not sourced from food or edible things, and so it was named as second generation biofuels. And then third generation was algal biomass. Algal biomass was called third generation because in both the generation, first and second, we are utilizing any type of crop. We are using trees, we are using stems, we are using something which we need to grow, and it takes time to grow. Trees need time to grow. Stem needs time to grow. Any type of crop. Jatropha, huh? The Jatropha oil is a second generation because Jatropha seeds are not edible. Jatropha also needs some time to grow, and canola or any other sugarcane energy are first type of. These also needs some time to grow. So uh, to overcome this disadvantage of this time, a third generation was created, and that was algal biomass. So algae are now being very much researched nowadays to produce biodiesel. Algae biomass are now being used to produce biodiesel, and these also produces very high quality biodiesel, biomasses, and we can also grow it in a very closed environment, and we do not need any vast amount of land for it. We can do it inside a four inside a four-walled room also. It just needs some instruments. So the third generation came to replace the second and first generation. And then finally there is a debate on fourth generation. Some says that fourth generation is a genetically modified algae to enhance biofuel production, that we need to genetically modify the algae so that the biofuel production will be higher. It will have a higher lipid content. It will have a higher growth rate. It will have this. And some are saying that fourth generation is a amalgam of some uh, chemical changes on the algal biomass or some mechanical changes on the algal biomasses. But yes, fourth one is a type of modified algal biomass. So these generation just came from time to time just to overcome the previous disadvantages of those crops. So I hope that you have understand that what are these generation and why they came, and now what can be the future generation. So the fourth generation, this one, genetically modified algae, might be utilized because there has been many research on normal algal biomass, and now genetically modified algal biomass are being used to enhance the production rate of biofuels. So let's come on to the sixth question. Which part of food has a higher specific heat? Bark, heart, pith, or leaves? Okay, no guesses. So I'll show the answer. Bark. Bark has the highest specific heat, and if we see but first, what is specific heat? Before knowing that, what is specific heat? Sorry. Specific heat is the quantity of heat required to raise the temperature of 1 gram of a substance by 1 degree Celsius. So it is nothing but the amount of heat required to raise the temperature of 1 gram of substance by 1 degree Celsius. So which material has the highest specific heat? It is wood bark. When we see the graph of this specific heat versus temperature, the red one, this line represents the wood bark. So it has the highest specific heat at any time when we compared it with wood or char. So bark has the highest specific heat when compared to other wood materials. And now let's move on to the seventh question. The potential sources of high value products from willow biomass is the components of polymer of biomass, the specific extractive of bark, the specific extractives in the leaves, or A and B. Basically, a willow is nothing but a type of plant. So the question is that what from what is the high what is the source of this high value product in willow plant? So the answer is A and B. The component of polymers of biomass and the specific extraction in the extractives in the bark. So this is what a willow plant or willow tree looks like. When we see the weight basis, on the weight basis, willow is almost similar to other hardwoods in terms of energy content. When we see the weight basis, but when we go into the volume basis, then there is a misconception. Willow has a lower density. So due to this lower density, the energy content when compared on volume basis, when we compare on the volume basis, the energy content comes less. So people think that Velo has a lower energy content when they compare to on volume basis, but in fact it has a higher energy content when we compare in terms of weight basis. So yes, it can be used. Willow plants can be used uh, to replace the hardwood for energy utilization. So the eighth question: which of the following is true for the production of sweet sorghum? Is it A, requires less water and more fertilizer, requires more water and less fertilizer, requires less water and less fertilizer, or requires more water and more fertilizer? Just a hint that sorghum is a type of edible plant and a first generation type of it produces first generation type of food because it is edible. And any type of guess that what might be the water and fertilizer requirement for it? Any guess? If you want to make a guess, you can say on the mic or write in the chat box.
Less water, less fertilizer.
Correct. Less water and less fertilizer is the right answer. So sweet sorghum is looks like this. It looks like a brown corn, you can say. So sweet sorghum is is many variety of sorghum grasses whose stalks have a high sugar content, and it contains both soluble and insoluble carbohydrates. And if we look on the what is the soluble carbohydrate it is glucose and sucrose, and insoluble insoluble part is made up of cellulose and hemicellulose. So yes, sorghum grass is both. So sweet sorghum is has both edible and non-edible. It has both type of sources. So we can produce both type of energy from it. First generation also and second generation also. The advantages of the sorghum is that it requires less water, so it is drought and salt tolerance, and has a very short period of growth. It grows in about like 4 to 5 months, and it yes requires less water, requires less fertilizer, and also has high conversion efficiency of light into biomass energy. It has a very high efficiency also. And so the next question is based on sweet sorghum only. According to the global fuel ethanol production in 2016, which country is the largest producer of sweet sorghum? Which country do you think has the produces the largest sweet sorghum? Any guess? Anyone?
Brazil.
Okay, someone has guessed Brazil. Any other guesses?
China, no, China.
India.
Okay, India. Any other
India.
guess? So yes, I can hear a lot of India, and we produces a lot of sugarcane. We are dependent upon sugarcane, not sweet sorghum. Uh, the answer is United States. United States produces the largest amount of sweet sorghum, and if we see the data of 2021 or 2022, United States produces the highest 11,375,000 in the unit is in 1,000 metric tons. So it produces a lot of sweet sorghum. And the next is Nigeria, followed by Ethiopia, Sudan, Mexico, and then India. So India stands at sixth position, and China stands at eighth position for sweet sorghum. But the highest producer is United States. We produces mostly sugarcane. Brazil and India both produces sugarcane, and United States produces sweet sorghum. Okay, so the last question of 2022. The delignification of the biomass for bioethanol production facilitates in decrease in saturation of plant cell wall, increase in saturation of plant cell wall has no effect, or increase in saturation only in middle lamella. Any guess? Any type of no. So it's increase the saturation of plant cell wall. When we delignify the biomass and produce bioethanol, the delignification means that we are removing lignin. Delignification, the term here means delignify. D means to remove lignin from the biomass. So when we remove the lignin from the biomass, we are removing more lignin from the plant cell walls because plant cell walls has that lignin. So the higher amount of cellulose will be present in the cell wall, which can facilitate the production of bioethanol. So the answer is increase of saturification of plant cell walls. And yes, this was the structure which I have shown you earlier also, that lignin is present with cellulose. So we remove this lignin which is shown in brown color, and then cellulose get fibrillated, and they are present to for so that we can chemically change any type of chemical changes on the cellulose to produce uh, bioethanol or any type of fuels. So before moving to assignment 2 of 2023, out of 10 questions of this assignment 2, 7 were from the past assignment 1 and past 2021 and 2022 questions. There was a numerical in this time which was based on year 2021, which I discussed earlier in the slides in this video only. And if someone has not gotten those who have joined the session late, can see this presentation at YouTube, and this video will be uploaded in a day or two, and you can easily see the whole assignment 2 of 2021 and 2022.
So can we get a link for that YouTube assignment for the assignment?
If
I'm trying
you
to search, but I've not found them.
Okay, if you see the go to the chat box, I've shared that link. The link is of last week. So in that playlist only, in that playlist, I will add this video. So the link will be generated tomorrow. But you can see that video in that playlist tomorrow. Okay, so the second question of 2023, there was a question. I have skipped some questions, the seven questions which were repeated, and only kept three questions which were different this time. So there was a question this time on dark reaction in photosynthesis process. I have explained you the light reactions and dark both in the previous. So who were present earlier in the past hour? Do you want to make any?
H2 is transferred to CO2.
Yes, correct. H2 transferred to CO2 to form sugar and starch. Dark reaction and one more biochemical process.
Biochemical process. We
Yes.
need to mark both,
You can
both
mark
A and
the
B.
option D
Both A and
also, which says
yes.
both A and B.
A
So yes, the answer is both A and B. It is a biochemical process, and H2 is transferred to CO2 to form starch and sugar. And those who have joined late, I will explain again. The light reaction is also known as photolysis reaction and takes place in the presence of light, and it takes place in chloroplast. It is about the light reaction, and light reaction is the first stage of photosynthesis process in which solar energy is converted into chemical energy. And so light reaction is a photochemical reaction, not a biochemical reaction. But as the question was on dark reaction, so dark reaction involves the transfer of H2 to CO2 to form starch or sugar, and this does not take place in the presence of light. So it is not a photochemical reaction. It is not a photochemical reaction, rather it is a biochemical reaction. So the answer was both A and B. So the correct answer was D for this question. Okay. So there was a question this time which shows that the answer was 7. If we go for if we go for the seventh question of 2023, the question was which of the following is true for light reaction? So the NPTEL is showing that the answer is all of the above, but it is not the case. The answer is H2O molecule into H2 and O2. You see, as I've explained earlier also, that the dark reaction is a biochemical reaction and it involves H2 to CO2 conversion. But a light reaction is different. It is a photochemical reaction where dark. So the answer for it is answer C, splitting of H2 molecule into H2 and O2. So there was a, I don't know how this error came in NPTEL. The correct answer was showing all of the above. Rather, it is splitting of H2O in case of light reaction. I hope you have got this, everyone. Any questions? Okay. And now the last question. A question number 8 of this year was what is the effect of lignin content on the biomass on the accessibility of microfibrils? The answer the NPTEL is showing directly proportional. That it, but as I've told you earlier also, that lignin act as a sticky substance. Lignin is a sticky substance and it holds cellulose and hemicellulose both. So if a degradative enzymes comes to attack cellulose, lignin will protect it. So if lignin is higher, the effect of degradative enzymes will be lesser. Enzymes will affect lesser because lignin is protecting it. So the answer should be inversely proportional. So the correct answer is A, inversely proportional. And lignin occurs in close association with cellulose microfibril. So it is always expected that decrease in lignin content would in turn increase the accessibility of the cellulose microfibrils to degradative enzymes. Have you understood this?
Sir, for valuation, which one you will take? Because NPTL answer is showing directly proportional.
Yes, yes, yes.
And if we mark the inversely proportional means?
Actually, we will also contact NPTL regarding this. That
Hmm.
the answer has been somehow changed, and it is wrong.
Okay.
So
Hmm.
if they accept the proposals as according to this reasoning, because this thing has also been taught in the uh, week 2 lectures.
Yeah, that's right.
So the answer inversely proportional will only be counted, but for
Okay.
that we will first contact the NPTL team.
Okay, okay. And it is not displaying after submitting. Anyhow, we don't know which is the answer. When we are discussing here, so we get to know
Okay, okay,
the
okay,
answer. That's why.
okay, okay.
And can we get the notes or something for problem solution, sir? Because sometimes we are unable to join the meeting also.
Okay.
Can we get some notes like that?
Actually, there are not any notes, but this presentation, this whole video, if you are not able to join this meeting on live basis,
Okay.
then
Huh.
you can always watch this video on a YouTube channel. Just
Okay.
write the subject name NOC23-ch33 week and then week number, week 1, week 2, and you will
Okay. Okay. Huh.
get that video. Also,
No, video we will get, sir. This problems solving link you are sending, no, through email. So
problem
that I
solve.
am
Yes,
asking.
yes, yes.
To solve the problems, so if I unable to join, because last week I didn't join, so during that time, how to access the problems?
The deadline for the that has been finished, I think.
Hmm.
Those, but if you want to see the uh, previous week discussion, I'm sharing the link
Hmm.
in the chat.
Hmm. Hmm.
So from that link, you can see the last week video, week 1 video, which
Okay.
discusses all
Okay.
the week 1 problems. So it is a recorded
Hmm.
session. This session like this only,
Okay.
and if you've missed it you can see that on YouTube, and you just bookmark that video, and you can subscribe to that channel also. So whenever I will upload this video, the currently which we are
Okay.
recording, you can
Hmm.
immediately see that in case you have missed it.
Okay, sir. Okay.
Okay, so anyone has any doubt in this question, the effect of lignin content on the biomass on for the accessibility of cellulose microfibril to degradative enzymes? Anyone? Okay. So, uh, thank you everyone. And the presentation, I have completed week 2 solutions of 2021, 2022, and 2023 in this. And I hope that you have cleared all the doubts of the assignment which we have discussed here. And if you have any type of question, you can always email me. Also sharing you my email address in case you have any type of query for the week 3 uh, questions, or any you have to learn about any other concept, particularly any type of concept in the next video. Then you can just email me. I'm sharing you my email address. Also, I will include those parts in my next video also. So I have shared my email address in the chat box. You can save the ID and email me about the any type of query, anything on that.
Sir, can we get this YouTube link by mail also? We
By
can
mail,
upload.
actually there are very much people who are joining here, and we don't have any database for that currently, but
Sir, is
mm,
it possible to pass through the NTPTL that mail we are getting?
yes, 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 you can ask, always ask them.
Problem solving.
You can
Yeah,
ask that,
problem solving.
you can ask the NPTEL,
We
but
are trying to get the NTPL, but it is not possible to get.
okay, but in just like you are saying that, is it possible to get the YouTube link by email?
Yeah.
You do.
Sir, I would request you. There is a one uh, progress in our this one
Mm-hmm.
record.
Okay.
If we start our session now, NTPL,
Mm-hmm.
there is a progress mark. In that you can post your videos like that on the progress or like that. The
Okay.
link.
Okay. Okay.
We have the announcement now where we get the problem solving sessions link.
Yes. 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 Yes.
So is it possible to paste in that one? Whosoever is joining this class now will get able get access of that.
Yes. Yes. Sure. 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 I will.
That will be better for us.
I will
You
ask.
don't have to carry for the total data.
I will ask the NPTEL team and then confirm you. But
Yes.
before that, if it doesn't happen, then you can just wait a minute. Can you see the screen? I am sharing my browser currently.
Yes. Yes. Yes.
Can you see my browser?
Yes, sir.
Okay. So the link which I have shared you, if you go to that link and just go click here on the channel and then subscribe it. If you subscribe here, then whenever I will post the video, you will get a notification on YouTube itself. Okay. Regarding that query, that if we can share the link in any type of message or in the announcement form, I will talk about that with the NPTEL team. But until that clarifies, you can just go to the YouTube link and then you can subscribe the channel and you will get posted about the links.
Yeah, sir. Even I feel yes, we can do that.
Okay.
Yeah,
Okay.
we are
At least we can subscribe the channel so that till we get any update from the NPTEL, we can have this access.
Yes. 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 Yes.
Thank you for this.
Okay.
we
Thank you,
got
sir.
Okay. So everyone, I hope you have learned something, and we will meet you next week. Thank you for your patience and thank you for such an interactive session. Thank you, everyone.
Thank you, sir.
Later, sir.
Thank you, sir.
Thank you.